Usually they come out in black on black, and so that's why I'm asking. Yeah, so welcome to the virtual Vancouver Friday. So this is a meeting that we were planning to have in Vancouver, and you all know why it's now online. And we cut this down to 3 hours. This doesn't mean we have to use the entire 3 hours, but we have reserved 3 hours. And one of the things that the research group does a lot is bring together different groups and try to find out how we can make progress together. We just had one of these events on Wednesday this week, where we talked with OCF about some security issues. And this workshop is intended to be a little bit wider, more long-term in view, because we are not talking about specific standards that already exist or are nearing completion, but we are talking about standards that are being created as we speak. And the two groups we bring together here is on one hand the 1DM liaison group, which doesn't really exist, just like the IETF didn't exist for its first 50 years or so. And that group is somewhat informal meeting of people from different Internet of Things standards development organizations, and they are trying to get common data models for IoT devices established. When we say data models, we usually include interaction models. We are a little bit sloppy with our terminology here, but for today, I think that's pretty much okay. So that's 1DM, and 1DM is amazingly successful in that they have both a set of a 3-digit set of data models that are nearing completion, as well as a common idea of a language that is used to represent those data models. So that's a really interesting group. And on the other hand, we have the Think2Think research group, which is a research group inside the IRTF, which is IETF's research arm. And we are interested in bringing researchers and standards developers together to get progress on the long-term problem of a true Internet of Things. So the IETF is creating standards, and we are looking at what's missing, what are the gaps, what needs to be done, not necessarily done within the IETF, but some of the gaps we find, of course, will then be addressed by the IETF. So that's the background for today's meeting. And in Vancouver time, we are starting with the introduction. This is the 10 minutes here. And we have 3 big headlines. We have versioning and evolution as one headline. We want to spend half an hour on that. We have 1DM key technical issues, and I neglected to actually update this properly. So we have the major part of the time for that, from 9:40 to 11:20. And in the end, we should spend some time about prospects of actually getting standardization going for SDF, for the language 1DM has defined. And yeah, look at how the IETF could be useful for that, and what are the next process steps we have to do to make that happen. And yeah, then we have a little bit time for a wrap up, seeing whether we want to do this again, and so on. We want to have a 10-minute break in the middle. Now, this is in the middle of Michael's time, so at some point we should just say, okay, Michael, our brains are on overload, we need a 10-minute break. And so the time that is taken down here isn't really 100 minutes, it's only 90 minutes. And there need to be some 10 minutes in there. And we will nudge you, Michael, to actually start this 10-minute break. Are there any comments on the agenda? Okay. Logistics, the pointer to the live notes that we are taking in HackMD. HackMD is a kind of Etherpad just for Markdown documents, is in the WebEx chat and on the slides here. And well, you wouldn't hear this if you didn't know about the WebEx meeting, so I don't have to say anything about that. So that's the introduction. Anything else on the logistic side? So if you hear me not speaking for a while, this is me muted and coughing a little bit. I hope it's not that coughing. Good. So let's start with the first item on the agenda. We have been talking about versioning and evolution for a while in the research group. We have this thing in the research group which is called Wishy. Ari, can you expand that abbreviation for me?
Work on IoT, semantic, and hypermedia interoperability in some order.
Thank you. So we tend to have a call a month or maybe twice a month on some issues, and on two of these calls we have been discussing versioning already. And it turns out that evolution and therefore the need for versioning, revisions, features, whatever, comes up at the number of different levels in the 1DM activity. And one of that is, of course, that the models themselves evolve over time. Of course, they evolve during initial development. That's maybe when we need a slightly more sloppy form of versioning, but we do need some versioning there. And then at some point they get agreed, but of course they do get fixes, they get additional features and so on. So they evolve. And we have to have a way to handle this evolution in such a way that not every change is extremely expensive and disruptive and so on. So that's one area of evolution that we need to manage. And the other one is that the SDF language that we are using to represent these models, this language will also evolve. This will get new features. I hope we will manage to stay completely backward compatible over time, but even that is not a given. So we want to be able to have different versions of SDF coexist in one ecosystem where we might have data models that have been developed at different times based on different versions of that language. So this is not about evolving the models itself. Of course, model evolution has to interact with this, but about evolving the language. So these are the two things. I'm going to make a little bit more detailed distinctions later, but we have to keep that in mind. Also, during the development of 1DM, it's often confusing. We talk about things like schemas and never remember to say, are we talking about the schema that is part of the model to describe the data that are being exchanged as part of this model? Or are we talking about the schema that defines the syntax of the language? Both are schemas, and it can become very confusing. So we have to be a little bit careful to always say which level we are arguing on. So I've said versioning all the time, and actually after about 40 years of doing this, in various protocols and environments, it has become clear that versioning is not necessarily exactly what you want, because versioning was invented for software. But this is not software. This is an interface definition between two software components or multiple software components that evolve on their own timelines. So it has turned out that we actually often can better describe the evolution of some interface in terms of features. So which new features are there that weren't there before? And features might take the form of a simple capability indication. So one end of the communication says, oh, by the way, I understand this new data format or this new interaction pattern and so on. So it's kind of a unidirectional announcement, and it's only becoming actionable when it's actually operated by the peer. So a peer that simply ignores the capability indication doesn't need to know about that capability indication because it's not going to use that capability. So that's one kind of feature. And the other one is one where actually the fact that a feature is part of the communication really changes that communication. So if the members of the group agree that they all speak French, after that we might want to start speaking French, and then people who come in and don't know what French is or don't know the language will not be able to communicate. So that's a very different kind of feature. It's one that really is more of an agreement than a simple capability indication. And we often are negotiating features, but sometimes we are simply using them. And the most important aspect of evolution here is to prevent false interoperability. So when somebody says a sentence in French, we need to avoid somebody else acting on that just because the same sentence also has a meaning in German or whatever. So preventing false interoperability is one of the most important concepts in the feature of version mechanism. So what is a version then? Well, a version essentially is a feature or set of features that have been blessed a bit, so people are willing to talk about them collectively using some version number, and then we just straitjacket those features into a linear space, which is very natural when you think about evolution of a single piece of software, because that software has that feature implemented or it doesn't have it implemented, but this happens in linear time to a certain extent at least. So it makes sense to say, oh, this is version 2 and this has the following 3 additional features. So that makes sense for software. It makes much less sense for an interaction specification. But still, it's sometimes nice to just roll up a number of features, in particular if they are interdependent in some way. So you might have something like a feature SDF 2.0, which would mean that there is a number of features that we now take for granted in any new models that use this newly versioned dialect of the language. So that's a version. And then I have a third term I want to throw at you, which is revision. So the specific files that make up, I could say data objects, but I'm going to make it really grounded by saying files. These might have revisions. So I'm changing the order of something in the model that makes things easier to understand for a human reader of the model, but doesn't change its semantics. Or I'm fixing a typo in a comment or in a semantic, if in an English language a description or something like that. So that's a revision that is not necessarily creating a new version. Well, that's of course not true for all typo fixes. So we just had a big fix where we changed the spelling of the word writable And of course, you need to know whether you are using the old version or the new version when you make a revision like this. But I think the important thing to keep in mind is that the lexical state of a file that is used in this environment, a model, a data model, or maybe even the schema that defines the syntax of the SDF language, changing that doesn't mean that we change the interface. And all the versioning and feature string stuff we are doing should be about making progress on interfaces. So to make this specific, in a model, we might also introduce features. So we might have a lamp, and that lamp might or might not have an RGB feature. And depending on that, its behavior is going to be different. That's another thing that is relevant for evolution, because very often you do model evolution in a backwards compatible way. So you need to know whether a specific implementation actually had that feature or not. So there is a difference between the capability of a model and the capability of an implementation that implements this model. And again, we are going to do roll-ups here at some point. So at some point, we say we have a completely new version of a model that unifies a number of features. And on the language side, this is really interesting, because any particular model that we are looking at is going to use one specific language. So there is no negotiation. It's just going to say, I need features A, B, and C. And well, sometimes you have conditional parts of a specification and so on, but usually you try to avoid that complexity. So a model will declare, it simply unidirectionally declare which features it assumes, and that's then an interpretation requirement. And of course, there may be optional things, still things that can be ignored. So if you don't know what a protocol binding is, then you don't really care about features that relate to protocol bindings. Now, one interesting thing that also happens is these models need to live somewhere and get names. And then you reference a model by name from a different place. So for instance, we might include definitions from one model specification into another specification. That would be inclusion or import. And of course, also an actual device may reference a model specification. It may not be interested in the specific revision of that model, but just say, I implement that model. So sometimes we reference documents that are meant to evolve. We do not always reference one exact specific revision. So that's one thing the Yang people are trying to do. They are trying to attach a specific revision to every single Yang specification. Then when you point to a Yang specification, you need to indicate that specific revision. But that, of course, makes it really hard to fix a bug somewhere, because you have to change all specifications that reference that specification that has been fixed. In software, we usually use something called semantic versioning. So you say something like, this is using version 2.5 of that other thing, but we don't really care whether it's 2.250 or 253 or something. Please use the newest one you have. Yeah, that can have some interesting consequences in an interface specification. That is, of course, also orthogonal to the question, which of the features of a reference specification are actually used. So you may want to say, I'm using that specification over there, but only feature X, and I don't care whether feature Y is in there or not. So versioned references are an important part of the versioning model. Now let's talk about the interfaces where we need all this stuff. As I said, the specification uses a version of the language, and the language may have evolved and may have got additional features. And this is not just a matter of the language specification having evolved. You also want to know whether the language implementation you are using actually implements all the features you need to run this model specification. And it's usually rather expensive to have a specification evolve and require that all implementations implement all new features. And that is typically something that then simply doesn't happen in reality. And so it's much better to say, okay, this is an SDF 2.0 specification, but we only really use the features A and B, and we don't care whether the implementation actually uses feature C. So that's something that may be useful to make it easier for an implementer to manage the evolution of the language they implement. So this is one interface, and there we need versioning of feature indications for the language. And the other one is the use of model specifications by other model specifications, and of course, ultimately the use of a model specification by a device definition. So we need to find out whether we want to indicate a specific revision here to be on the safe side, indicate some semantic versioning to have a way to fix some bugs, indicate features. I think that's really the most interesting part here. How can a lamp say, I'm a lamp and I'm using that model over there, and actually I'm also offering certain features here. I'm requiring certain features that from the model that may not be required by other people. Okay, so this was my quick introduction into the subject. And now, of course, I would be very interested in hearing what your point of view is, what we should be doing around the versioning and evolution issues of the SDF language and the models described in it.
Right. Wow. Thank you. That actually, it really makes sense to think of these things not, as you just pointed out, not as like how you version something, but from the point of use of the version. So the references and understanding how the references to a version are used is really probably the most informative thing that we could do to sort of help decide how this should work. And it immediately made me think of, I do not want to have to carry around the logic, or I would prefer not to carry around the logic to apply different schemas to different instances of things. It seems to be really cumbersome to have a set of models where different models are pointing to different schemas, and where the way you use it is just by having the whole referencing the schema to validate them. It's better not to have a lot of those, I guess. So there's some informative conclusion already that we can kind of understand that the way you use them. I don't want to have to pile up a bunch of strings in a single reference, for example. So that, I guess it says indicating features as individual things. And I guess I have some questions, right? So as capabilities versus agreements, it seems like capabilities are mostly by nature backward compatible. And so you might even be able to add those without changing any kind of version or anything, and just sort of, add those, provided the right testing has been done. But then when agreements change, that's when I think it sometimes calls into a more rigorous review of whether you need to change a version or, what's breaking and what isn't breaking, this sort of thing. Does that make sense with your thinking? That capabilities are mostly backward compatible, but when interpretations change, it's more of an opportunity to break things?
Yeah, if in a perfect world, the capabilities are completely orthogonal. So you can switch them all on and off, and it means something. Of course, in reality, that's not always entirely true. And you might have one capability that implies having another capability. The interpretation agreements, of course, those really require preventing false interoperability. So they are much more disruptive, but they are also great opportunities to clean things up. So when things moved from HTTP 1.0 to HTTP 1.1, the only place in the history of HTTP where that actually happened, they could take out a lot of craft of the headers that had accumulated that you had to put in there to work with both older and newer HTTP 1.0 implementation. So sometimes you just want to do that to simplify things.
Yeah, that seems really consistent with the idea that you don't want to carry around too many different schemas, but you might need to have a couple to deal with cases like that. Good examples.
I have a question. How do you deal with systems that are intrinsically dynamic, where a feature could be time-based? So something is very important now, but it may not be important tomorrow because we're in an industrial environment or something to that. So so my question is, are these versioning and features could be time limited or time-based or time-stamped to make the difference between current information and stale information?
One case of that is deprecated features. So if you want to remove a feature and you want to say after a certain time this is no longer going to be supported, how would you represent that?
So I could imagine this happening more when we're talking about specific features being available in a device, so that the device stops supporting TLS 1.0 because we really don't want to accept those insecurities anymore. And we might want to put a date on when that happens. This is less about features that a specification language has. So essentially, a specification that is using an older version of the specification language will be around indefinitely. It's not going away. It's going to be in some archive somewhere. So it's harder to talk about flag days there where features actually vanish. But of course, for new stuff, you would then say, for new specifications, please use that feature and don't try to work around not having it.
Like Python, Python 3. At some point, people might start saying, oh, we don't really process Python 2 anymore, but that's not yet, So, but both exist and coexist. Yet there's a graceful way to phase out the older one over time, and that's probably what we want to head for. But you probably have to support it sort of indefinitely, right? And in terms of an organization and as a standard, and it doesn't just immediately stop working everywhere.
Yeah, I think it's especially important for IoT devices where we might in fact have brownfield devices that can't be updated for some reason, but we might want to know they're quarantine them on an isolated network. Now if that how that relates exactly to this, but I think that information is valuable for security.
Yeah, those dynamic features that might be or may not be available occasionally. Of course, doing discovery even occasionally or when detecting something is changing. That's one way to tackle that. It's kind of common for the hypermedia-based systems.
People hear me? Because I wanted to say a few things already, but I have one button too much muted.
I hear you now, Otter.
Okay, so I think there is a huge difference in data modeling and what is actually implemented in a device. And I think the examples that I hear so far is really signaling what a device can do. This has nothing to do with the data modeling and the version of the data model itself. At least that's my grasp of what we're trying to do with SDF. So what can be implemented or what is defined in a data model and what can be implemented can already be a subset. And it's up to the ecosystem to convey what is the subset. And of course, all the required elements of a data model needs to be somehow transported for the data model. We are not talking about the interaction models and to detect those kind of things, at least not yet. Does that make sense?
Yes, but you also have to keep in mind that that additional feature that a device might provide, the presence and absence of which you want to model in a data model, that may not have been known at the time the model was originally defined. So you are evolving the model to be able to express the presence and absence of that feature. And that actually is a feature of the model, of the evolved model, that you can do that, which you couldn't do in the earlier model. So the two levels of talking about this are actually interrelated in practice, just because features are added over time.
Yeah, so if you want to do, well, if you have model A and you want to add something as an optional, that can be done at any time. You still need to recognize that's an optional thing and whether if it's available on that implementation or not. If you want to add something that is mandatory, then probably you should not call it data model A, but data model A version 2, so that everybody in the it's known that there is a fundamental change because something mandatory has been added to it. That sounds like a big step, but basically you're creating a new model which encapsulates 90% or even more of the older model if you want to add something mandatory. And I think that's a normal way of doing versioning.
Right, and the interesting case is where you want to evolve the model, you want to make something mandatory. So for instance, let's say that we now have decided all IoT devices in the future need to support TLS 1.3. But of course, there's all this brownfield stuff out there that doesn't know about TLS 1.3. So as long as that stuff is out there, you may also want to support TLS 1.2. And so you have a mandatory part in that model that the peer device doesn't care about because it only has TLS 1.2. So this is a classical feature from the device interoperability point of view. And therefore, you should also be able to handle it like a feature on the modeling level.
Yeah, I'm not sure if the TLS stuff is an example. But if you want to be compatible with data models, you have a client and a server. So you can have servers that just do data model A, and you have also servers doing data model A v1. And if you want to do it correctly on the client side, you want to understand both. And then you need to make sure that for V1, the extra stuff that is mandated is handled correctly by that client. So there is some somewhat forwards compatibility thing needed on the client side, or at least more upgradability of the client side than from the server side. If everything would be upgradable, then you could do that. But in brownfield situations, you will never have the possibility that everything is upgraded to the latest version. If you're doing it in a factory, it might be, but something like in a smart home where people buy devices from different vendors and have just a mixed bunch of features, then the likelihood is that device A will be using an older model which could have been upgraded, but it did not do that. I think that's quite common.
Yeah, I agree that TLS is maybe not the best example here. That's maybe one of the things we might take as homework, coming up with a number of good examples that actually illustrate what we are trying to do here. So we can point to those specific examples when we explain our design decisions.
I totally agree with that. We need to sort of figure out what we're talking about. Also, the examples help us stay focused on whether we're talking about models or language, which seems to be the big split here, that we need to talk about versioning of both. And then, of course, how much language versioning do we embed in the models, which was something that I think Carsten mentioned earlier as being a specific issue that we would need to consider. So I think we seem to be getting, pardon me, we seem to be getting really well informed about, what the issues are around versioning and how to do this. And maybe it's time to start talking about some strawman or design patterns for both the language and for what we would call SDF models that use the SDF language.
So looking at the time here, would this be a good spot to switch on the SDF specific issues? Because one of the issues that we were planning to talk about was this versioning.
Yeah, it's literally at the top of the list.
So, Carsten, did you have more you wanted to wrap up on this slot? Or shall we switch now?
I think we should go home with an idea of what we want to do until we have next meeting of this kind. And I think taking home the need for examples is pretty useful. But of course, in the end, I think somebody has to write this up. So I would also be looking for people who are interested in doing some of the writing there.
We don't have now Jaime in the call. I remember he started writing something in one context about the versioning. That could be a good way forward. And we have quite a bit of material on the minutes where which we could learn something. But if there are more people interested on this topic, please do let us know. I think it would be very useful to write these things down, that we have a place to refer to. What do we mean by versions and features, and what do we consider as a reasonable way to use those? We do have hopefully alignment across multiple IoT protocols and data models on this.
May also be worth pointing out that we are currently doing we're adding some versioning considerations to the SNML data representation format. So that's an area where these considerations might be useful right away. So if you're interested in that, that's going on in the core working group of the IETF.
Also, if anyone has any good other sources where these aspects have been perhaps analyzed in more detail, that will always be very useful information for this work. And apologies for the background noise currently at home.
No, that's good background noise.
Okay, good. Well, thank you, Karsten. And yeah, anyone else who's interested to work more on those, do that, let us know. Maybe now is a good time to switch then on the STF issues. And we could then jump perhaps straight away on the versioning and think about how should we handle versioning or features in that context. So Michael Koster would like to take the presentation.
Okay. I thought I had one up. Hang on just a second. Now, what are you seeing here? Something weird happened with my sharing. Oh, wait, here we go.
Architecture slide.
There we go. So I have both these presentations up. What I have up over here is actually this presentation that I've updated, but I wanted to sort of center around this because I know there are some people on the call that maybe haven't been keeping up with every one data model meeting. So let me know if we need some context and I'll switch back to this deck. But to stay focused on what, pardon me, what we wanted to accomplish today, we we had a one data model meeting earlier today and did some review of these and kind of prioritized on where we think the hot topics are, which are the bold ones at the top. But here's our whole list of things, and so I guess at this point we need to figure out, do we need a little bit of background on one data model, or should we go ahead with the technical issues based on the audience? Does anyone feel like they need to, and they're totally lost about what one data model is, especially after having shown this? Basically what we have is events, actions, and properties, and data types, and objects and things. And if that's not enough, I'm happy to explain a little more. Okay, well, why don't we go ahead and just interrupt me if there's something that we just can't figure out. I think that answers the question on hierarchy ontology, and then we can refer back to that when we do that discussion. So version scheme. So as I think that fits the topic of something, because what we're hoping to do with one data model is very soon come out with something that people can count on to be stable and that we can open up wider access to. Currently, the GitHub is public, so anyone really has access to it. But what we want to do is sort of start being a little more consistent about our releases and policies and all that. So the version scheme is really at the heart of all this, figuring out how we want to move this forward in a way that's people can both depend on what things working the way they have always worked, you know, some consistency there, as well as us being able to evolve both the language and the models that use the language, and in the way that's coupled appropriately, right? And so I'm not trying to totally decouple it, but I think that just frames the problem. So version scheme for the language and version scheme for the models could, you know, and would be more or less different. And I'll share my experience with models. What we have at SmartThings, we currently don't version individual models, but there are a number of people who think that that might be a good idea to try to do. So we're kind of having the same discussion now. What we do at SmartThings is we have a policy of saying we don't version things. This is very similar, by the way, to OMA lightweight M2M and maybe what a lot of other people do, like even OCF or whatever, in terms of the models. There are rules that you can add things that don't break what's existing. And if you change too much and make it unrecognizable or change the underlying contracts, then you create a different model. And we sort of, that's been the rule, and that obviously the rule sort of, it has its limitations on two fronts. It doesn't always work the way you think it would. So it has corner cases that do break and need special exceptions to handle. Plus it doesn't really, I guess, you know, allow for the kind of evolvability that people want, I think. And I don't know, you know, that creating a new model is also a breaking change, I guess is another way of stating that. So they feel like versions might be a way of, you know, having medium between the two and not the worst of both. So, but we don't really know about that. So that's our experience with versioning models anyway, is that we currently don't do it, but there's some framework and numbers and tags that people want to start trying to use. And so even the result of our decision here might, you know, because we're hoping to contribute our models to 1DM as soon as all the licensing can be figured out, you know, and I think we're really close to that. So versioning models is one discussion. Then versioning the language, I think we have, we kind of have a proposal that we version the language using semantic versioning, and that we create a directory that is also a GitHub branch that has in its path somewhere the version number. So it might be something like /SDF version /1-1-1, for example. And that might be a directory that points to that has both a schema and a markdown file, and that's a version of the language, if you will, and an accompanying schema, an accompanying schema that validates instances of models that are said to conform to that version of the language. So that's the first sort of part of the proposal, is that we version the language in terms of GitHub branches, and we tag the branches, and those are actual language releases that look like directories that have semantic versioning in their path somewhere. And the details of that can be figured out. So that's actually kind of a concrete proposal that we have on the table that we would do if no one objects, if there's not a better way to do it, et cetera. When is a language version, you know, done and all that, it is sort of like Kirsten, I actually presented a lot of good rules for that, and we could, you know, just have those as policies and do that. I don't know if there's a technical issue with that, but I think, you know, we need to talk that through, you know, if there are any. So versioning the language, you know, the rules would be when you know, maybe the rule, we have to figure out the scope of changes that trigger a version and whether we want to have a lot of versions or just a few. And I would say, it'd be best to have just a few versions, but we do have to have a way to evolve the language between versions. And it's not clear whether we want to have language features show up without a version number changing at all, right? So I think that's part of what the policy discussion or the sort of how it's done discussion on that. That's one factor anyway. So I think that summarizes what I know about versioning in terms of where we are. So we have kind of a proposal for the language versioning. I'd hope we could add features to the language without, bumping the version, but maybe that'll have to be in separate branches, and we'd have to figure out that policy. And then for the models, I think that there was one further idea that was coupling the models to the versions in a way that we would have what we call equality in the SDF model to distinguish it from attribute property and all those other overloaded terms. We have equality that's a key value pair that says SDF version, and then it sort of points to that, a URI that points to that version. And that's the version that this model is expected to conform to or to be validated against also. The schema that's found in that directory would validate that model. So from what I heard earlier, though, and in the thinking about this, that might have its own set of problems to require that kind of coupling. So I guess at this point, I'd like to open up the discussion and get people's opinions on those three things, both the model versioning, maybe that features can be added and we sort of don't worry about version numbers for models right now. Use the backward compatibility rule. And for language versions, the proposal is to have a GitHub branch with a schema and a markdown file and other associated supporting files in it that changes when each version changes. And then also the third thing to require that the models point to the schema that they're expected to validate against. And those would presumably be backward compatible so that an older model would validate against the newer schema, but I guess that's subject to discussion also. Ideas, opinions, any of that really bad?
Let me just make my ceterum censeo here. The fact that a model complies with a specific syntax for a model is almost unrelated to the question whether it actually uses a particular version of the language.
Yeah, I had a note from you saying that, and I really would like to hear more about that and elaborate on that, because it doesn't, I mean, it sounds like more explanation is needed to really fully grasp that concept.
If we fix some problem in the meaning of the language, that may mean that a specific instance can be interpreted in the language before the fix and in the language after the fix, and means different things there. So the fact that this instance, this specification instance, actually validates under that schema is kind of nice, but it's not telling me what version of the language I actually have been using.
So the version of the language could change without the schema changing if we change the meaning of something, and that might even be just being more restrictive about something, perhaps.
Yes.
Even.
And vice versa.
We can change the schema, the
without
syntax.
changing.
Okay, schema equals syntax, right?
Yes.
Yeah. We can change the syntax without changing the meaning just to fix the typo, is your writable example.
Right.
So would playing that forward against the proposal for language versions, and assuming that every substantive change in the language requires a new version just for the time being, does that mean that either of those would require a language change because it has a descriptive document, the markdown file, which could change the meaning of something. And also it has the schema, which could be changed for typos. So would we say that it's an inclusive or of the changes in either the meaning or the syntax that would trigger a language version change? I mean, that's the most, restrictive. It seems like that would that would prevent there from being conflicts.
Yes, in the general case, yes. And maybe cases where you get away without that. For instance, if you clarify something in the definition of the language. So, yeah, I think that any version or update to the language needs to enable a specification to indicate that it is actually using that update.
Yeah.
And whether you model that update as a version number or a set of features mostly has a bearing on how inexpensive it is to make a change like that. So features are always less expensive than versions.
Yeah. Right. And so obviously there are editorial changes that you can go in and just change in the directory without bumping the language version.
Yeah, that would be revisions.
Revisions, yes, revisions. But anything that adds a capability to the language or adds a feature to the language, whether it's a capability or a change in the agreement, requires a revision.
It requires a revision, but not necessarily a new version.
Not necessarily a new version. So there's a class of things that could be feature additions that don't require a version. That's what I'm interested in, because that helps us limit the proliferation of versions.
So if a language has a good set of extension points, you may be able to extend it a lot without changing the version. So for instance, in CTDL, we have this extension point called a control operator. And by defining a new control operator, you can add capabilities or features to the language without changing the version of the language. And by looking into the specification, which of these control operators actually have been used, you find out which features you would need from an implementation that actually implements all these features.
All right, yeah, extension points, and that's basically, I think, it's roughly analogous to what we're doing with the W3C Web of Things, where we can have protocol bindings in a separate document that can be extended and changed, and there's this sort of well-known extension point that doesn't generally require updating the thing description document, even though it can change the way that thing description instances are processed ultimately. But it's through a clear extension point, and we separate the versioning. So yeah, that's a good and other architecture features that you can think of that help with that process. I mean, extension points is one. Are there others? Well, that's good to note anyway. Yeah. So would that be a reasonable set of, I don't want to get too much into, 1DM operational stuff here, but if that sounds like a reasonable set of rules to go forward with, if someone, on the 1DM side would, could write those up about language versions and continue to use the sort of the directory method and GitHub branch and all of that. And no one's objected to that. So, okay, thank you. What about model versions and versions of models? What about this idea of just like what everybody's doing now? You can add features but you can't change contracts without, and just create a new model if you do. It seems like we have some experience with that. I know from Smart Things, we have some experience with that where we end up deprecating the old model eventually because people just would rather use the new model. It gives the customer a better experience. So, you know, it's not that hard to get people to switch over, but it takes time. You can't just force people to go and write software and release it on your schedule. They have to do it on theirs. So those intervals vary across the different vendors you work with and all of that. So it's the same. I think it's the same thing with us. Is there any discussion on that, or any ideas about refining the rules or how we should deal with that? Because I think we could start writing that down too. I mean, so maybe we should just have a little open discussion also on, you know, if we were to try to version the models themselves, would that cause an unnecessary sort of overhead in managing things? Okay, well, maybe there's not really a lot of controversy here. That would be good news.
I'm afraid might be more, because I think at least the revision information, also like for language, also for the models is useful. But then how and whether that relates to the versions is another thing.
So the way they do some specs, I think it's lightweight M2M, is you have both the date and the version in the string, and the date can change without the GitHub version changing. Am I right about that? They do something there that changes.
So in OMA we're right now reconsidering the version model, and that is it's an interesting ongoing debate. What's the best way of doing that?
Versioning the models. I remember that discussion. Yes. Okay. Well,
Yes.
what are the thoughts on that from your angle?
So no final conclusions that I could deliver from OMA side. I mean, I think Klaus is here on the call. Klaus, for example, presented one good set of guidelines that is currently being considered in OMA. But one thing that I guess what we have agreed on, that we do need a way, if we are deprecating models, as you indicated, that you are doing, for example, in Smart Things, you do need a way to indicate whether either on the model that has deprecated the old model or in the old model something has been deprecated. That you have probably that's a new revision of a model, because it doesn't really change the interface, but you have something indicating there that this model, there's a new model that replaces this model. And of course, the one way of doing that is with the version numbers. But since that version numbers have their own issues, this kind of a pointer to the new version or back or forth is a more flexible way of indicating that. That might be a useful thing to adopt.
Yeah, so we use we have a status. So in 1DM, it would be a status quality that would be, they have an enumeration of live or deprecated or proposed, for example. It could be a life cycle. You design a life cycle with some states, and we use at Smart Things, we use proposed, live, and deprecated. And so a proposed capability is sort of while it's in staging, and even for a little while after, when we make sure it doesn't need any changes, then it goes live, and then it's stable, and then when we replace it, it becomes eventually deprecated, and that it goes through that process of having both available, but they're just different names. But what an additional thing that you brought up is that we could, when we deprecate one, we could say replaced by, so like with the IETF drafts, when you go on the draft system, it says it says, oh yeah, the name changed, but this replaces that draft, right? And so you could put a tag in the old, when you deprecate, you could say sub whatever by, I forget the word now, but succeeded by or whatever. Supplanted is the only one I can think of, but we could put a couple of qualities. We could add a couple of qualities that allow lifecycle management of the model instances themselves in the header. I mean, we don't have to design the whole thing here, but we could talk about different sort of the merits of different approaches.
I think it's really important that we spend some time thinking about the model metadata that go into that header. So I think this versioning feature mechanism is just part of things that we want to be able to say about models without actually changing the model itself, because the thing being modeled doesn't care about which version it was modeled with.
Exactly. The model metadata is really what that is then, right?
Yeah. Yes.
Yeah. And that's currently just mostly in the header. But I think if you could think about it as when you add a class, you're also changing the model metadata. So if we were to add an interface class to virtualize views of things, then that's actually a change in model metadata, and it adds qualities. And the set of qualities is also, I guess, model metadata, but specifically those things in the header tell you about. The other things are sort of effects of the things. So if you have a version that changes the feature set, and that's sort of the qualities and classes. So, right, I guess it does go back. Yeah.
There's something interesting happening about evolution here, because in the IETF we have this myth that you can change everything in a document before it becomes approved. And that's simply not true. So by sitting there in one form and being implemented by people, a revision or a version of a model acquires some weight, and you never can get rid of that weight by pointing to any kind of procedures and so on. The procedures just don't properly reflect what's going on in reality. In the IETF in particular, in the Yang world, they are trying to have this really well-defined transition from a model that is still in draft stage and a model that is finally published. And you can do certain things at draft stage and cannot do things once they are published and so on. And I'm not sure that this is not just trying to fantasize a reality that never will exist, because people will be using draft versions of something and will be building systems with them. And at some point you need to decide whether you will want to accommodate that reality, or just react it, but then reject it in a well thought out, well considered way. We really want to get rid of that draft 15 version, and we deprecate it, and it's now gone. So I think that would be a nice thing if we could crack that particular nut and find a good way to handle version transitions that actually reflects the fact that versions exist in drafts, and people sometimes go ahead and implement those drafts.
Oh, we see so much of that with IETF, and even with things that aren't even adopted by IETF that people just published using the IETF system, like JSON schema, for example.
Exactly.
There's an issue of that right now. So I totally agree with you, and I think that your sort of realistic and also sort of supply side solution proposal is the right direction. There is a weight with evolution, and you can't make it go away. You can't even push it sideways very far, so it's going to roll down the hill down the track. So we need to deal with that in a way that's realistic, and we need to probably have rules that evolve as our designs evolve, and we recognize that things do become more stable, but not to give it such a binary character in our work process. Yeah, I totally. If we could figure out a better way of, just even improving how we deal with that. Yeah. Great discussion. Any more comments on versioning and evolution in general? It feels like we're kind of grounded on a lot of this. So I need for 1DM, we need a proposal. And I think the idea of tracking what's happening in lightweight M2M and tracking what's happening, and sort of let's maybe use this as a forum for keeping this versioning. And we already have, I guess, with, it's already a thing-to-thing topic. So already have the right sort of closure around, maybe let people know that we're working on it.
One other thing I'd like to bring up, actually, in W3C, we've recently been discussing DIDs or identifiers.
Yeah.
Is it ever appropriate to use a DID to identify a version? Because they're
if you wanted to create a DID method that's for versioning, like did version, maybe that would.
No, I don't know. I'm just asking the question because you just notice your ID numbers here. And
yeah, I'm just talking about how DIDs work in general, but yeah.
Yeah. So having, so what is the, reference that you use to refer to a particular version of something?
That's a URI. We're proposing to use
so
a
URI.
URI.
URI, that's right. And so DIDs are URIs, so that's fine. But I just don't know if any of the other stuff, like for example, do you ever need to have, encryption or certification or authentication that the version is the exact version you want? Is there any other reason for the other features of DID?
If you need to validate that an instance is claiming to have an identifier and need to cryptographically verify that, that's always an option, but that's not really in the scope of what we're designing, right? Or how does it, where's the
yeah, I'm also thinking that the container, if its container is certified, like the data model has signed or something, then you can handle things that way. For example, you have a list of prerequisites that a system needs, and those prerequisites have versions, but you sign the entire thing. You don't necessarily have to sign the individual references. I'm just bringing up I'm just doing it just now, and I'm just wondering if it matters at all. It may be out of scope, which is fine.
If there's some coupling that we need to be aware of, then let's address it. But I'm not seeing it right now.
Yeah. Okay.
I think that's again something that the framework should handle. If you do something with a device, then of course you that whole chain of a hardware identifier that you put it up and you load your software correctly, that is signed, etc. So it ends up that you have to do something correctly with your data models, but it should be part of that validation chain, not part of the modeling language itself.
And actually, just generalizing what you're saying, I think that versions are an example of I have certain prerequisites that have to be satisfied for me to work, right? And so one of the things that have to be satisfied is having, an interface of a certain version or whatever, or better. And so what I'm really doing is stating my requirements. And maybe other requirements like root of trust, maybe related, but aren't exactly versions. They're other things you need to have satisfied, other conditions.
The whole point is, if you take a deployment into account, then you want to know a version of a meta model that can be on the wire. And if it's on the wire, then it better be implemented correctly. And I think certification programs of different organizations should be taking care of those kind of things.
Well, actually,
I was assuming that the existing methods for for cryptographically verifying instances of a file format like JSON signature would cover, you know, that doing that in a framework that you would get a checksum, you would essentially checksum the input, you know, you would be able to checksum the reference model and cryptographically validate that,
Well,
you know, something like that. But I'm
the interesting
maybe
word we brought up here just now was certification, which is basically, you know, someone stating that, yes, this implementation satisfies this data model or whatever, right? And so that's an example where you might have somebody signing something to certify something is in fact true.
you do on your device, you do certify that these tests have been done, and some of those tests do reflect back on validating that you've correctly implemented a data model.
Yeah, but it's not about the data modeling itself. It's the whole set of doing a device correctly with all the features that it belongs to. And that is way more than just implementing the model correctly.
Right. And I do want to say in other standards groups I'm involved in, like OpenGL, there's a big problem with people lying about their capabilities. That a device would say it did something when in fact it did not, or it hadn't actually passed testing. And this caused all kinds of problems. Try and shame people.
Yeah. Well, that's why you have a logoing program. So, and you have to have, well, it's extensive that you have what you have to do to have a certification program, and shouldn't be allowed to lie. And if they do, you should be able to call them out. So all the organizations that I've worked with that had a certification program, if you're putting that sticker on that you're certified and you were not, then you can get a letter from the lawyers. That's strong. And if you're doing something that is not according to the spec and you had certified, but you launched a different version of your code, then you also can get an email from the lawyer.
Well,
but that would be friendlier, but that would be fix it as soon as possible kind of email.
right. But I think the letter from the lawyer implies that there's a contract or a logo program.
Well, and that's actually the key. That's something that we haven't decided yet in 1DM, you know, where what we're going to do about that and how whether and how. So that's an interesting topic, probably to take in another discussion, because it's probably not a research topic for thing-to-thing research group, but it is very interesting about, you know, when you do decide to certify something, then, you know, is there a cryptographic chain that you establish, et cetera, et cetera.
Is that IETF and W3C don't really have that infrastructure in place, those legal constraints, right? So they're more voluntary.
You know, and so much turns around whether you do certification or not, as I'm finding out with getting involved in this niche program in Zigbee. So I think that there's a big dividing line on organizations that certify things and organizations that don't. And I think there's a lot to be cognizant of and sort of what kind of one we're building.
Well, I think there is a huge difference if you're doing things for IoT and that are working in a distributed way on the local network, or it goes to a central system. So when I was working with XMPP, I also said, why don't you have a certification program? And the answer was pretty clear. Well, if you can't connect to the XMPP server, people will start using another client.
That's called protocol versus platform.
That's well, it's not really a platform, because I think smart things can also be regarded as a platform, but it's not in the same league. Because if the XMPP client doesn't work, I will get another XMPP client. And that's the same thing in general with the internet. If my browser is not working, I will take another browser. And I guess everybody that's on the call has more than one browser on their system, because some browsers are good at good at things and some are worse at better things. So you will take the ones that, for the task, you take the one that is most suitable. But that's not interoperability, but it is one of the reasons why they can get away with not having a rigid certification program. You're relying that two devices that somebody is buying suddenly have to interact. That's a different ball game, because then people will just throw those devices out if they don't work, and people will not go back to that brand because there is no update mechanism easily done. I think that's why certification programs for ZigBee, OCF, those kind of UPnP, DLNA, those kind of things were pretty important, but it's not important for a browser.
Yeah, that's definitely. I guess we need to work out what the coupling is, because certainly the coupling, we want 1DM to be used in those organizations that certify devices, and the version coupling, I think, to get back to our topic, is something that we probably need to design appropriately. Right. Recognizing that our users are going to be certifying devices that use what we produce as input in one part of their process. Okay. Other comments on versioning? We followed the previous discussion on versioning with our discussion on versioning, but that doesn't mean we're going to go down the list in order. So I guess at this point, how close are we to the break? Time check.
3 minutes. Okay. 3 minutes away, but it's so this is a perfect time.
Let's organize the discussion, the next part of the discussion, around which topics we want to prioritize on this list, or add others, or whatever. Does that make sense for everybody? Okay. So the ones that yeah, go ahead.
No, just it sounds good.
The ones that we in one data model just a couple of hours ago, we're interested in talking about are in bold here. So those are sort of our choices, and it has to do with the class hierarchy thing. There was some, you know who you are with the issues, things you want to do there. Complex data types. There's some question about a use case there having to do with what happens when you really want to have a data type that has a lot of elements and maybe is hierarchical itself. How do we represent that and model it? There's some interesting discussion around how we define events and actions, and sort of a suggestion that we look at event condition action as being a framework for defining what events and actions are, and at least gives people some grounding in what they're for. There's some discussion about long-running actions and how the state machine works, and maybe we have events versus some read-write status, and how restful does that need to be? That's interesting. Instance bindings and protocol bindings. The question was sort of, to what extent do we need to model the target architectures that these one data models will be used on? So we're talking about specifically the sort of thing that a W3C protocol binding does, where it takes a generic description and has some URIs and method descriptions and things like that. That says here's how you use the protocol. Instance bindings are just sort of, for those that aren't deep in 1DM. 1DM doesn't really have data schemas that says this is what it looks like over the wire. Even it basically just tries to define things more generically, which is how we get the issue of complex data types. But nonetheless, we just try to say very, very generic. This interaction has these data elements, and then we rely on another descriptor in the ecosystem protocol to say what this data schema looks like on the wire and what protocol elements are used. But that's kind of a fuzzy boundary, because we do have things in one data model that can describe data schemas to the extent that You could just use them as payload schemas if you wanted to. So that's an interesting discussion. And then these other ones, multiple instances of a definition, virtualization, have to do with how you how you have a generic definition that can be expanded and sort of implemented in a number of different ways. Read-write constraints about how restrictive you want to be with the definitions, and is there really any data that's inherently read-only? Stuff like that. How you handle reusability with defaults. There's some questions about ID numbers that are used to have compact wire representations for different protocols, but they're used differently, and how do we represent them, and so on and so forth. There's, I think some of these at the end are like enum, URI, using a URI to define values of an enum and then having them map to different serializations. How would we handle that? And how do we handle namespaces? So these are all topics that that are sort of on the big list of things to refine for SDF. They don't all have to be done for the first version, but we do need to prioritize what we are going to do. And we have ways we're doing all this stuff now. And so a lot of these are sort of enhancements on the language that we can decide, what the merit is of when we need them and if we need them, et cetera. So if anyone has any strong ideas, I think I've just briefly explained what each of these is, so we can sort of, after the break, come up with some priorities of what we want to discuss for the second half. Sound good?
Yeah, I think that we really should focus on the interaction patterns. So somebody brought up event condition action,
Yeah.
which is a triple of words that use the same English words as the terms event and action in 1DM, but there's no relationship whatsoever otherwise. That's really interesting.
Yeah.
And also the definition of what an action actually is would be interesting. I wouldn't even start thinking about what an event is because we are so far away from a common understanding. But maybe we could make some progress on action here today. So I really would like to get some focus on that. And if we have some time left at the end, we might want to talk about complex data types, but really, let's talk about interaction patterns and in particular the action pattern for most of the time, and then maybe complex data types after that. I propose we make a 10-minute break now and reconvene at 10:45 Pacific.
Okay. Sounds good to me. Thank you, everyone. Talk to you soon.
Okay. Thank you, everyone. We'll continue from here in 10 minutes. Meanwhile, you can also think about if you have some additional points on the which of these items you would like to prioritize, and then we'll take it from there. By the way, for everyone, if you at any moment find it hard to jump into the discussion, feel free to put your question in the chat room, or you can put there Q+, like I just wrote down there. That will indicate for us chairs that you would like to talk in the queue. But otherwise, since we are still a relatively small group, you can also feel free and chime in if there's a break in the discussion. Okay, so soon, 10:45 Pacific time. We're going to be starting in less than a minute. Okay, so everyone find their way back from the break. Michael and Karsten, are you here? Koster, can you hear us? It seems
Can
we
you-
have to.
I can hear you, Ari, so the system is still up and running.
Okay, well, that's a good sign. Thanks, Walter. I guess we're gonna need Michael Koster to come back for the continuity segment. But anyone else? Any more reflections on what would you like to prioritize for the remaining key issues?
Sorry, I mislaid my microphone. This is one of these small lavaliers that you can clip anywhere.
I guess all the meetings we will start, and also during the break have a few minutes of getting audio back and up and running. I see Michael Koster is at least sharing screen. We don't hear you yet, though.
I was just on mute. I saw that I needed to reshare the screen, and so I'm ready to go again.
So before the break, we did discuss that we could prioritize the interaction patterns on the next topic, and we originally were planning to continue this until 11:20 Pacific, so that would be about half an hour more.
Okay.
But we can see we can maybe also shrink a bit the final 2 slots. We maybe necessarily need half an hour for the IETF standardization considerations. But let's see how this goes and how much over time we shall take it.
Well, I think
we get started with the.
Go ahead.
Sorry, go ahead.
I was saying, I was just going to jump in. I think the priorities are good because what we really need to do is make sure that we have an architecture that makes sense. And I think the items that we've prioritized are those that sort of have a bearing on the architecture and what the actual concepts that are being represented, et cetera, in the model. And the rest of these are more, how do we, more language issues, which we need to take up as well. But I kind of agree with prioritizing the architecture. So did anyone have any other ideas on things they wanted to prioritize? I guess maybe you asked that just before I sat down.
Yeah, I did. Maybe people were still coming back from the break, so there was no comments on that priority. guess if there are no other comments, we can get started with that one. Go ahead.
Okay, so just to get everyone to the same place, there's a sort of UML diagram for the meta model, and we have events, actions, and properties that are composed into reusable objects. And the events, actions, and properties share reusable data types. And I guess that probably the best example is if I might have a state property on off and you know, an on off state property that's a Boolean. I might have an action that takes that is the setter for that takes the same data type as the payload, and I might have an event that gets generated when the property value changes that sends the same data type as the payload. So that's the idea of a reusable data type. So this is sort of our whole UML diagram. Ontology, you might call it, but it's really pretty simple. But this is our meta model for one data model. And so what I think where the discussion starts is sort of, we have events, actions, and properties. Okay, and the current working definition is pretty loose. It says that properties represent the states of things, and they're generally readable and writable. But there's another issue. There's another item on this list that has to do with, you know, what if you only have pub/sub, and so properties may not always even be readable and writable depending on the binding. But nonetheless, you have properties that represent state, and they're generally accessible in some way and settable in some other way. And sometimes they're settable. They're not settable through the application, they're read-only or whatever, but those are properties. Actions are sort of the way we represent commands, typically commands that you send. So they're a little more complex than just changing the state of a property. They may have to do with changing the state of multiple properties together. They may have to do with starting something on a device that might take some time to complete, and it might complete correctly or it might not complete correctly. So actions are more about, how do I get this? It's the affordance for how do I get this, you know, to perform something. And events are the typical definition of event is a happening. Something happens on the device, and so event is the affordance by which I learn about things that happen on the device. So an event is a class of definition, and when we make a definition for these things, like in one data model, the maybe have some examples, but let me know if you need next examples. But a property definition basically is sort of like a data type definition, and that's the most recognizable thing. And I think, as we said earlier, no one has a problem understanding what properties are and how they work. It's sort of like a data definition. You know, it has a type like number or string or Boolean, or it might have some extended typing like uint8 or float or something like that. And what we do though in one data model is we create a semantic anchor for the definition of a property that sort of becomes part of one of these objects. That's also a higher level definition that's reusable. And so the properties look like data definitions, and the data within a property, the data that a property carries, is also reusable, those data types. So for example, a temperature property carries a temperature data type, and that temperature data type is defined as having, you know, a set of permissible units like Fahrenheit, Celsius, Kelvin, Rankine, and maybe some others if you're, depending on what your domain is. But so properties are really well known, but events and actions are not quite so well defined. So what we say an action is as I said, something that you make an affordance for making your device or the thing your device is connected to, you perform something. And so the definition of an action has a semantic anchor for what the action is, and as for example, a light bulb might have a turn on action and a turn off action, or a you know, dim the light or brighten the light or something like that, that have more than just changing the value of a brightness. There might be a time slope involved, transition time, or other kinds of things involved with it. And when we define an action, it's really the semantic anchor of what the action is and its input parameters, and perhaps its output parameters as well. So like we said, sometimes you can invoke an action and then get some response back that tells you, you know, whether the action is done or whether it's going to be deferred, or, you know, those are all things that we need to model because different devices and different ecosystems handle these things in different ways. So really what we're doing is we're not so much trying to, from first principles, to decide what the meaning of an action is. What we already have meaning, because we have these devices like Zigbee devices that have commands, and Z-Wave devices that have commands, and UPnP devices that have actions. And those definitions are already pretty consistent about what those mean, so we just decided to call that an action. Events are a little, pretty much the same thing. Rather than try to really define from first principles the semantics of what we mean by event, but we already have examples of UPnP having events, of Zigbee devices sending notifications when property values change, and so those all fall under what we call events, and they're defined in one data model as having a semantic anchor for what this semantic definition of this event is. Like, it might be just a general device alarm, something's wrong. It might be something very specific, like an over temperature or over current event. And we don't really try to say that because existing devices and existing, infrastructure is already modeled, is already defined, and we just need to figure out how to model it. So, that's sort of the background on what we mean by events and actions in one data model. And then this morning we had this discussion around event condition action pattern. And I was quick to point out, maybe this would be a good way to start the discussion, that really the way we use events and actions in IoT applications is closely related to the event condition action pattern, because we have something that happens, we have a rule that evaluates it, and then an action that's generated to take place. So for example, in our SmartThings platform, we have the events coming in from devices, and the motion is being sensed in your living room, or someone turned the light off in the kitchen, and there are rules that we set up and behaviors that we set up to respond to these events, and they generate commands to, oh, when this happens, do this other thing. So to me, that's the way that events and actions on IoT devices that we're talking about are used is in a pattern that's very similar to event condition action. So with that, I open up the discussion.
So this is Hank. I brought this up because we try to incubate something like that with a Yang automation framework in IETF like 2 years ago in the context of Yang push. Then there was a big uphaul, and some of the authors just went away, and now there is a sibling effort in NetMod about the ECA framework and the very basics in the management domain and ops in IETF. So there are other places where this formalization is being adopted and done, and I think that is good, because the more people do it, the better it is understood, and the better it is understood how conditions and actions actually relate, and how, for example, an action could be another event emission and such. So maybe an action is creating a new event, and so on, have this chains. And so we are not doing this alone. If you would adopt that model at some point, and that is actually, I think, a good start.
Yeah, the other observation that I made, now, I guess to back up a little bit, I'm not deeply aware of any formal event condition action framework. So there may be some internet drafts or other, sort of formal writing. I'm sort of aware more of a general design pattern. So I guess I'm speaking more of the general design pattern, but it seems also that we have a lot of interest in this group defining more than just events, actions, and properties, but also defining in a way that's reusable and interoperable, has all the qualities of the other work we do, to define things like the context of devices, so machine parts or locations or whatever, and also to define behaviors, and behavior meaning essentially things like rules and scenes. If I want to group a bunch of actions together and call them a scene and perform all these actions and set all these property values when, as part of this scene, for example, for home automation. And scenes are actually used beyond home automation. They're used in commercial lighting and really a lot of other places. And so there's a lot of interest in our modeling being extended to go beyond just events, actions, and properties of devices and those affordances that they impart to the things that they're bolted onto, but also the software orchestrations and other sort of context that goes with them. So in a way, I was interested in, and also this idea of event, condition, action being something that we could anchor on as far as how we define rules and things like that. I don't know though. I don't know. Again, is there already a well-known sort of framework that has very narrow definitions for event, condition, and action that we need to sort of take into account here, or is it the general pattern that you're talking about?
I would not call it well known because it is now rekindled in you, but it is narrowed in scope, because the explosion in complexity can be vast here, especially with the conditions indeed. So it should be basic, and it should be simple to interpret by every data model, or representable by every data model. That is one of the goals here, I think. And to my from the top of my head, I cannot remember the name of the draft, but I will post it to chat in the next minutes.
Okay, well, it may be that we need to understand how our definitions of events and actions relate to what's being defined there. But I think our job is to really say, are we happy with our definition of what we mean by event and what we mean by action, and what do we need to improve that or change it as needed?
I see there's a question on the queue.
Point out that this is really a fallacy of using the same terms for some completely different things.
Mm-hmm.
So event condition action systems are the subset of rule systems. You may know about, don't know how to pronounce this in English, Rita systems. These are really the most powerful ones. And in a rule system, you describe the behavior within one system. So if an event happens in one system, you look at a condition, and then when the event has happened and the condition is fulfilled, you perform some action. But this is completely unrelated to the issue we have here, which is where we define interaction patterns called properties, events, and actions. And these are always between two systems. So you might mix those. So you might use an incoming event as a trigger to evaluate a condition and send an action back to a device. But that's completely outside the scope of a data model describing the interaction, because the whole ECA stuff is happening locally on one system. And yes, we may want to have a language for describing these things and so on, and mobile code and lots of beautiful things can be done there, but it's just something completely different. So the interesting thing, if you look at the data modeling aspect of these things, is that an event looks exactly like a property, because both just have one data type, which defines what the thing looks like at the moment when it's actually interchanged. So from a data modeling point of view, events and properties are identical. And you can see that by the fact that we have frameworks like QuadN, where we have notifications, which some people think are aspects of properties. The property tells you when it has changed, and other people think are aspects of events. And you really have to look at the details of those interaction patterns to find out what are the actual semantics. So there is a very, very, very big difference between a temperature sensor telling me, oh, the temperature is now 31 degrees, and the temperature is now 32 degrees, and so on. That's a very different thing from a coin checking device that is telling me somebody put in a coin and somebody put in another coin. In one case, you could just lose one of these events, and the other event would still mean exactly the same thing. In the other case, it's really, really important to not lose those events. So they are semantically very, very different. And the question in an interaction pattern always is beyond the data model. What does it actually mean for the thing to actually happen, to actually be triggered, and so on. So the event itself, and now I'm using the term event in the computer science sense, is of interest. So there are event-triggered and level-triggered concepts in electrical engineering, which also have this interesting dichotomy. So I think ECA is not going to lead us anywhere here, except that at some point it would be nice if we could feed the events that we are modeling here into an ECA pattern and use the same description technique, and then on the other end get out actions. And by the way, actions also have these interesting dichotomy between being non-losable. Somebody put in payment of $20. Now, what's the total paid amount? That would be an action of the non-losable way. And the other one would be set the set point of the thermostat to 32 degrees, where the actual action is idempotent. So I think we have to look at the details here and not let ourselves being misled by the beautiful thing that people only seem to know 3 words for these things, which are properties, events, and actions, but they all mean different things each time they use them.
Yeah, and really that was the point I was trying to make, to say that in our model, we mainly only describe the input and output data for events and actions, and we don't really describe much about what that does. So in many cases, especially when the 2 special cases that you brought up, and I'm only seeing 4 cases, I'm sure it could be more, but there's setters, which is what we call an action, but it's really a setter. And we call it an action probably because we're trying to map a lot of other device ecosystems and models that have already called setters actions, including SmartThings, including UPnP. And the other thing is a state change event, and which could be a change of an enum value or a change of a scalar value, and Boolean being an enum. And so that, it looks just like a property. So then, but we have these other things that are also called actions and events, and just to broadly classify them, what's not a setter is an action, is something that has multiple values and has maybe a long-running status and has these extra things that you can't model with a property. So in a way, again, it's sort of about having to map stuff that already exists versus being able to create a correct definition. I guess we have to figure out how to reconcile that. So then similarly for events, you have things that aren't just state changes of properties, they're genuine happenings. And as you say, they have qualities where you probably can't just arbitrarily miss one and lose one out of the stream. there's state changes in a state machine, whereas if you miss one, you don't end up in the same state. And actions are, I think that's a very good point, that some actions are just setters and they're idempotent and they don't have that property, and other actions do have that property, that if you miss an action, you don't end up in the same state, and the intended result is not what was expected. And I think this is all an artifact of what happens between two systems. And I think that's a correct framing, also an important framing, I should say. And I also agree that ECA, and I think it was what I was trying to get at, is maybe ECA isn't helpful in defining what we're doing other than as a use case, but it is sort of a use case in that I agree that it's helpful if we can define what happens between events and actions in a system as in some commonality with the ECA framework. So I think the interesting part of this discussion is, what do we need to do about reconciling actions that aren't setters and events that aren't property changes? And whether those need different classes, or whether, because modeling them on existing ecosystems tends to sort of squash those definitions. What do we do about that? What do we need to do, and what should we do? And first, was that like a reasonable framing or follow on?
So in GDP, they have used the idempotent property a lot. I cannot just say property here.
Quality in 1DM. Yeah.
Sorry?
We would call that a quality in 1DM, but it's also an attribute of.
Yeah. Whatever. So something is idempotent or it's not. And they also have this idea of something being unsafe, which is really about when you do it, it means something, and when you do it twice, it might mean the same thing or a different thing, but the fact that you did it means something. So I think these are actually 2 dimensions. We probably need a couple more dimensions, and then we can put the various usages of event, action, and property into this 2, 3, 4 dimensional system and be much more precise than we are at the moment.
One way to model that, one way to accomplish that in our 1DM framework as it is, if we wanted to look at just having events, actions, and properties, is we could have some kind of additional descriptors for events and actions that describe these things, like idempotency and safety and things like that. But it also seems like a model could simply model properties and have these additional frameworks as like protocol bindings. It's really going to another level of austerity in the modeling. But if you the core, right? It's saying, okay, we're already modeling events and actions essentially as data types that have these additional semantic sort of hooks that give them additional meta operations. Like, for example, actions are things that have multiple data items. You can invoke them, and there's possibly a long-running status. But we're really just we're still modeling the data, but we're also saying that there's a state machine semantic around it. Likewise with events, we're still modeling the data, but we're implying a kind of an interaction state machine with events. With properties, we're implying an interaction state machine that's not always there. It's read and write. And I guess another one of my points here is that often you have publish and subscribe, and you don't even have read and write. On the protocol, you have you upload all the state, and then you send incremental changes, and the read and write only happens at the digital twin or shadow or whatever you want to call it. That's somewhere else, and it's on the other side of it's the other system, right? So when we describe interactions between two systems, we don't always even have read and write. So there's a bunch of things, but it, you know, again, mapping onto these existing systems, actions and events make sense because they're classes of things that already exist that seem to seem to line up semantically. So would it, you know, what kind of approach would make sense? Would it make sense to just add things to actions and events to further describe them? That seems to me to be a forward approach, but also keeps this notion of actions and events, as opposed to having only properties that have different ways of interacting on them as another layer, which actually seems like an alternative model now that I think about it.
But we still need the distinction between something having input and output data and which are different in semantics, and something that may have input data or output data or both, but they really mean the same thing. So a property is of the second kind, and the kind of event that you have been talking about partially is that as well. But the difference here really is in the initiative. A property is always examined from the other side, while an event is triggered by the side that has this. So I think these are again two different dimensions, and we might be able to keep those terms because people love them so much, but we really should nail them down to be one interaction pattern and not a list of different interaction patterns.
So in in thinking of the boundary between two systems, and you could even think of a single system that has a boundary like this, what we have are, and to just restate what you just said, we have properties that are examined from the other side. I like that because it doesn't really say how they got there. Events and actions, though, do say something about the system boundary, and it says that actions are things that go from the right-hand side to the left-hand side, if you follow what I mean, that they go from the operation side, operator to the operate. Oh, what would you say that? I don't even know what the terms are, but actions go one direction to the device from the controller. I would call it a controller if I was in an industrial control system. And events go from the device back up to the controller. So actions go from the controller to the device, from one system to another if you split it that way, and the events go from the device to the controller. So is that, and so that's really the only thing that we say about them now. We say that properties are things that you can examine. Actions are things that are transmitted, and we could also say asynchronously, in a way, on demand or whatever, from the controller to the device. And events are things that are usually transmitted asynchronously, although we could think about them being batched, and we could think about different methods of obtaining them. They're happenings that have sequence dependencies, and I guess you'd have to say a little bit more about the semantics of events and around sequence dependencies, but then some of them don't. So if we only say that they're things that are transmitted from the device to the controller, and then we further characterize them in the model as being having these qualities of idempotency, safety, maybe we have to identify some things for events that say whether they're property state changes or happenings, you know, whether they're serializable or I want to say monotonic, or, you know, we come up with a concept like that that represents that you can't drop them, for example. Right. So I think I go back to the proposal, or if I was going to make a proposal, I would say let's keep actions and events because, as you say, people love them and they kind of understand that it has a directional meaning and it has an asynchronous kind of connotation. But we provide enough descriptors to really, in the model, nail down what they do.
Right. So, for instance, in actions, we have confirmable actions, so actions that actually give you something back at the end, and we have non-confirmable actions. And of course, you can use a pair of a non-confirmable action and an event to model a confirmable action. So the only thing that the confirmable action brings to the table is that it has an implicit connection between the invocation and the return value, which you would need to model explicitly when you compose a non-confirmable action and an event. And I think we just need to write this up and actually look at all the cases, including CRUD-N notifications and so on, and see how do they fit into this. And then we will maybe have three things, 3 bits we can set or not set, and we will have defined anything. And then we can just go ahead and say, oh, those combinations are events, and those combinations are actions, and those are properties. But this is just sugar on the real semantics, which is based on which of the bits is on and which one is not.
And also the notions of input data and output data, I think, along with that, right?
Yes.
That's interesting. Yeah, I think it feels like we could do that, but it also feels like we need to now go and think about, some examples. And like you say, does it really, the win here is if it can describe CRUD-N without having to add actions and properties. I'm sorry, actions and events, because they don't exist in CRUD-N. I'm not saying that's always how it should be done. It could be that we always want to model things that are called actions and events, but the mapping onto CRUD-N could be done without a lot of gyrations potentially. Although you still have to say how you send multiple things, and they may be a different URI. There's still a mapping task to do, where the system that was designed as a RESTful interactions from the beginning may not have things that are easily, well, I don't know, they have notifications of things. It's just a mapping task.
Well, notifications don't really work very well in REST, so people just kludge something on top of REST. But actions actually exist. The post pattern, of course, is the classical way to do an action.
Right, and it has these, right, and it has these attributes of idempotency and safety and confirmability, and all of those can be layered on it without breaking the semantics of post.
Well, just looking at how UPnP works, that's just an action pattern, just using SOAP. And for eventing, you have to have also on the other side, as a client, you have to have a server to receive events. And that's what they call GINA, generic event notification something. And
if we're using,
that's just working already for many years. So that CRUD can't do action is just, I don't think that's true. It's just you have to build something on top of it to make it easier for you, like SOAP did and what GINA did. And of course, if you do it using something like CoAP, then you could use the observe mechanism to get updates on it, on a resource.
Doesn't require a server, which technically doesn't require a server because it's just a long response.
No, actually, if you just look at CoAP, CoAP works because they have on both sides always a server because it's UDP.
Right, but if you just wanted notifications, you don't need a server. The client accepts the response as.
Well, the thing is, you're soliciting that the server sends something back to you, and that means that either you have to have an open connection, or you have to have a server to make that connection to deliver that message.
Yes.
And basically, I don't care what you do. So if you open a WebSocket, which is also plenty, I've seen plenty implementations that just uses a WebSocket for receiving events, because then you have just a
Absolutely.
pipe.
Yeah.
You have a pipe where you can dump that information upon.
So, and this goes right back to what you said earlier. It's like that there's this I forget what you called it, but like basically a layer, a transport layer is really what it is, or transfer layer, where you decide how this stuff gets moved. But the modeling itself on the data and the qualities of data don't need to be tightly bound to any particular transport operation. So if we can define data that's idempotent, it has idempotency quality, a certain safety, it's confirmable, whatever, you can send that as a post and call that an action. And that's what we would do in the modeling, because that's what everyone's familiar with. Likewise, for events, we'd come up with data that has particular qualities like serializable and monotonic and whatever, and we could define some levels of strictness or whatever, sort of like consistency, coherence protocols. And maybe even have also serializable being like that definition, right? So we could have different qualities of data that you could even define serializable locks if we wanted. And then those operations, though, whether you do test and set on them or whether what you do is part of the protocol binding. So if we could move it more toward that, and certainly events are always into certain bindings like pub/sub, and you'll always have that. But we should, what I'm learning, especially with looking at industrial controls and field buses and how they work and how cloud-to-cloud APIs work differently from local LAN APIs, even when implementing similar REST-ish protocols. The more we can abstract these, how we define things in the model, the better it is for mapping to these different ecosystems. Because the data model is going to be the same. The definitions, as we, from the terms, from the two system perspective, let's call it a client, is going to see properties as things that it can, I forget the word Karsten used, but it was really good. Things that you can, things that you can, you can have locally and interact with locally, cache them and stuff like that. Events are things that you receive that sort of happen asynchronously, that tell you about happenings that have to be delivered in order and all of that. And then actions are things that you send that are non-local, that have, they're not safe. Maybe they have side effects. They might just be setters, and they might have they might be idempotent and safe and non-confirmable. And they might look just like properties, and that you would call that a setter, but you could still model it as an action in the model. It seems like that's kind of the direction that, in terms of a practical direction, that we could head to really reconcile all of this stuff. And putting tags, putting them into classes in the model like action and event, provides a default sort of mapping to different transfer layers that kind of helps, I guess, the developers and humans keep track of things also, I think. Designers, if you will. Anyway, I'm like talking a lot. What do other people think about this?
One comment on the action part is that how I've seen it commonly described compared to a property is that when you invoke an action, you would get a handle that then you can inspect what is the state of the action, maybe cancel the action, and then or get more information about what's going on with the action. Whereas property, it's simply get, set, and you're done with it.
Yeah, that's kind of action, but there are also things like asking a device that has a probe to actually activate that probe and answer back whether the probe hit anything or not. So that's not, you don't need a pointer for the ongoing action. You're just starting something that has an influence on the physical world and want the result from that operation.
Well,
That's also called an action.
there is a time aspect, and if you already know what you're doing, modeling wise can take a long time, and you can model it already in a way that that time aspect is being handled correctly by the model. So if action returns and you get indeed information where you can access the time aspects, duration, progress, whatever on that action. This is just a normal pattern, and that has basically nothing to do with the action pattern itself. It's just again a pattern on top of the action pattern.
Yeah, you'd call it like sequence clock or something like that, where you would get multiple output data elements that had some element of timing and sequence associated with them. And then, yeah, you know, that's kind of the idea, that we define an action as an action in the model semantically, but we also define its input data and output data as having the qualities that we need to make it work right. So if it's input only, then
Well, that's why I think an action should just be something simple like a SOAP call. You define what the input parameters are, and you define what the output parameters are. Basically, just a C function. So you define your inputs and you define what is being returned by the function, either by the argument list or by the return clause of a C function.
yeah, I think that's what we do with actions today, more or less. We have input
Yes.
data.
That's I just make it clear that I think that should be the pattern. And what you build on top of it is again modeling, but it depends on what you want to model. And of course, we can prescribe a few patterns in how to do these models to make it more, to look that everything is more uniform. But basically, if something is different because the modeling should be different, I don't care too much. It should not affect the language. It should just affect the model.
I think I follow that. I mean, I think it's really talking about the same thing here, where
Well, if I just go back to my old days when I was very active in the UPnP forum, we had state variables. Yeah, we had state variables, which is like more or less like the ODM properties. You just have setters and getters on them, and then you have actions, SOAP actions, which is the same thing as we are now defining with ODM actions. And you had events, and that's what we had to subscribe on it. But you just define architecturally, you just define what kind of data it is, and also when you would when it would be triggered by something else, and that are the I think the concept still that we also do in SDF, which works pretty well. I could map the whole UPnP, all the architectures to SDF with not too much problems with it. And of course, the UPnP architecture fills in a few blanks. That's what we want to do with SDF as well. And if you want to make that mapping, that's up to you. If you just look the UPnP spec, they don't talk about SOAP. They just talk about what are state variables and what are actions and what are the events. The architecture documents describes then how these are being put on the wire. And I think we are
Yeah.
doing exactly the same. Yeah. It's,
Yeah, that is
fits
what
in my model. Yeah.
and maybe even a little more abstraction, but that is definitely the pattern. And I think the idea that having events, actions, and properties where we're describing just the data exchanged, and then not really by that I mean we aren't really specifying that you have to use a particular protocol. That really is in line with what you were just saying. That we know what actions are for, therefore creating side effects. And we know what events are for, and therefore observing happenings. And then we have all these other qualities that even if you were to define events without, even if they were sort of tightly coupled to protocol artifacts, you'd still have to specify constraints on what those protocol artifacts did. So we might as well try to abstract them and specify them as data artifacts, even though they're protocol artifacts. By that I mean an event isn't just a piece of data. It's understood to be a sequence of data items that have certain qualities of sequential, consistency, if that's actually overloading of the wrong term, but sequentiality, monotonicity, order. So an event is known as a series of items, an action is known as a thing that might have input and output data. But also we have enough qualities on the basic data to define them as data qualities as well. Meaning that they go with this definition. In my model, I'm modeling something where I'm getting data that has to be sequential. So I'm going to call it an event. But presumably you could also call it a property and require it to be sequential. But this is where I'm not sure whether we really want to do that or not. Right? So it could be like DDS protocol, where you have properties that come back as sequentially reported state changes, and you might define that as a QoS requirement in DDS as that you can't lose data, so you require that to be sequential even though it's state changes, for example. I don't know to what extent we want to allow those other things to, the other qualities to be applied, like the sequential, monotonic, and ordered only apply to events, or they just apply to any data in general. And that being said, what if I want sometimes temperature to be sequential and sometimes not? So, is there a late binding option? So I guess there's some implementation questions about how we structure the model around it, and that's where Carson was saying we kind of need some examples and to see whether they line up well with CRED-M mappings and stuff like that.
Yeah, I think that's a good way to summarize this. Like we have very good points on all around what we actually mean by this, and getting some examples and working through those to get a bit more clarity here. Because I'm looking at the clock now. We have only about 20 minutes time of the session.
Okay.
We have one more aspect we want to cover in this workshop. But Michael, do you want some final summary on this plot? What should be our way forward for getting more clarity?
So so to summarize, I think you'd made a good start at a summary, and that is that we recognize that that we're mostly describing data, and so what we want to do is describe the individual qualities of things that how events and actions work, even to the extent that actions don't always work the same way. And we want to essentially use action and event mainly as semantic anchors that come with an assumed set of qualities. But we also want to have, maybe we'll build defaults in the model, maybe we'll require some of them be specified, but that's all implementation detail. But essentially the takeaway here is that we want to define events and actions in the context of the qualities around the way that data are obtained and transmitted, but without mapping them to any particular protocol. So there are things like idempotent, safe, confirmable, non-confirmable, input, output, sequential, monotonic, you know, we need to come up with some words, but that's basically the flavor of it. That's the takeaway I have so far. Let's see.
I think most of those things belong to architecture. We should not put that in the model. Model is just data, and how it's being transferred, confirmable or non-confirmable, that depends on how you want to use it, and that's tied to the underlying architecture.
I think that was probably that's probably the wrong choice of confirmable and non-confirmable. But I think what I really meant by that was, when I have an action, do I expect there to be a return to the action, or is it more of a fire and forget? And I think we decided that needs to be part of the model. Maybe not in all cases. Maybe sometimes it needs to be constrained in the model, and sometimes it needs to be left open to the implementation. But
well, if you don't model return values, then it's a fire, and that's still I think it should be confirmed.
I agree. It's still confirmable, but it still can be fire and forget.
And if you then also have defined an event that if something changes on the system, that event will be sent. And basically you got your fire and forget and return value by an event. Those kind of things you can just model if you're just doing the standard eventing and SOAP like actions. And you can also create an action that immediately returns with data. That's also possible.
And as we said, we can create an action that returns a pointer to events that you can get to find out about the action, or returns events right in the channel that you invoked.
Yes, if you can get
using WebSockets or something like that, you could get to the events right back in the same channel. Sure. So what we want to do though in the modeling is avoid saying we want to be able to create a generic model that doesn't depend on any particular mechanism, but allows all those mechanisms and provides some application interoperability at the endpoint. The extent at which we can separate the data qualities and the information model from the interaction model is probably the interaction model, meaning that the protocol, the bus protocol or the network protocol interaction model, right? We want to describe the data interaction model in terms of, you know, events and actions and the way that those qualities, but we want to abstract it from the network interaction model of get, put, post, delete, publish, subscribe, you know, send, receive, or whatever they are.
Okay. I think we have now good set of material to work on this on the 1DM side. So we really need to move to the next segment now.
Okay.
Thanks a lot, guys. Good discussion.
We still have another topic, but that was, I think we covered the one that really made the most impact. So thank you again.
Good. Okay. With that, Karsten, would you like to take a lead on the last segment?
Yeah. So I propose to quickly look at what the procedural steps are to move the specification forward. So we have talked about technical issues for most of the meeting, but I think it makes sense to think about what we need to do on the side of organizing things. And in previous 1DM meetings, there was some sentiment that the IETF might actually be a good place to finish, to complete the SDF specification that we have been talking about today. And there are good reasons for that. There are also reasons against that. So I think it's not a complete slam dunk that of course we want to do that. We have to think about that. So on the plus side, we have aspects like well-defined process for turning out specifications. and a well-defined way to engage the community. So a lot of the questions that would have to be answered within one DM, how to handle the process, already are answered in the IETF. We could just use that process. Also, there is an established review process that is exceptionally thorough and generally provides a significant quality improvement. And I'm saying that as an author that has been on the receiving end of that quality improvement quite a few times. So it's sometimes a little bit hard to bear, but you have to bear it. If you want to create something high quality, you need some pushback on things that maybe weren't so good. And the third thing, because people know that this review process happens in the IETF, there is generally a good reputation of the documents that come out of the IETF, the standards track RFCs. So these are all good reasons why choosing the IETF would make a lot of sense. On the other side, there are a few things that we have to think about. And one thing is that the IETF is not exactly the leading organization in defining modeling languages. Typically modeling languages are defined by ISO in the same space in which, for instance, programming languages are also defined. There are things like UML and so on. For document modeling languages, also W3C is a well-known organization. So IETF is a little bit of an outlier here. On the other hand, it has happened. So for instance, IETF has its own specification for syntax for modeling text-based protocols called ABNF. IETF has recently done CDDL for modeling JSON and CBOR data. So it's not like this has never happened, but it's also not like all the community that's interested in standardizing modeling languages is already sitting in the room when we start that work. So we still have to attract some of those people. The second thing that we have to be aware of is that starting work in the IETF is a relatively arduous process, and it's also somewhat risky. So you don't always get the result that would be logical from your point of view. It's a little bit of a game. So usually it works, but it also can turn out to be a detour at the end that doesn't lead to a result, and that might cost us some time. And the third thing is that thorough process I referred to above, that just takes some time. So if we just want to do some rubber stamping on something we already agree is the right way to do things, we might go to OASIS or one of these other organizations that do rubber stamping. ECMA, what else do we have? ISO. They're usually good for getting things rubber stamped. So you can guess what my conclusion after thinking about all of these things is, but I wanted to make you aware of these considerations. So the next step we probably have to answer is, what is it actually that we want to standardize? And clearly we want to standardize SDF, the language, and there are several aspects to it. And one is, of course, the structure. So people who are defining this language think about the language as defined by a schema, which I think I have pointed out is not the whole story. There are, of course, semantics, and I think ultimately we have to be able to explain our processing models. So how are models that are written in SDF actually used? And I don't want to start this discussion today, but I think we need to keep in mind that we have to define this processing model at least to the level so we can actually define meaningful semantics. So that's one thing. And then, of course, there's also the data validation aspect, and that's currently done by JSON schema.org in SDF. And we would have to think about good ways to put these parts together. So, of course, one way forward would be to convince the IETF that the JSON schema.org stuff should be standardized. That has not happened yet so far, but there are people arguing for that. So we could put ourselves on the side of the argument. This is exactly what we want to do. Or we could also look at what else is there in the IETF that could solve that particular problem. So these are two different items, and people in the IETF haven't thought much about SDF style languages. They have thought a lot about data definition languages like JSON schema.org is trying to be. And we might get more pushback for the second item than for the first item. So given that we at some point defined what we actually want to standardize, the next question is, what is the right structure, organizational structure to do this in? And most likely the best answer is to create a working group in the IETF applications area, which has recently been merged with the real-time area. That's why it's called ART, for applications at real-time area. So that would be a working group. That working group would work on one or more internet drafts that contain the specification, would develop that in the working group, and at some point do a working group last call and ship this to the ISG. And one thing I would like to stress at this point is that it really helps to have implementation efforts out there. And in the best case, open source implementation efforts, but other implementation efforts also help. So people can talk about the successes and issues that they have had in implementing and using this stuff. I think we need to be able to point to those implementation of efforts at the point in time when we actually ask for creating a working group. So the way we get this working group is ultimately to run a BOF, which is a weird word the IETF uses for meetings in which we decide whether we want to take on some work or not. To do this, we have to create a charter. A charter is a formal text that defines what the working group that we are creating is supposed to do. It often comes with milestones that specifically decide what the outcome is supposed to be. And in order to survive in a BOF, we need to demonstrate interest. So we need to demonstrate there is a chance people actually will implement and use this protocol, and it's not just an academic exercise. And we also need to demonstrate that we have a chance to reach a consensus. So if there is lots of industry interest, but the industry simply cannot agree on something, that's not a good thing. I think we are pretty well positioned for demonstrating the chance for a consensus. So I think that's not that hard, but I think we need to have convincing material and actual people clamoring for it to get this demonstration of industry interest. But by the way, we also need to find working group chairs. That's not necessarily our job. It's also something that the area directors, the people who run an IETF area, might be doing. It's probably a good idea to have some people in mind who could run this process in a reasonably detached way. That's why I'm writing that they should not be the authors, but they should be different people, maybe with some experience in this space. So let's all think about people who who might want to do this. And final slide on the timing. The timing is very good with respect to the fact that a new ISG will be seated next week. That ISG will be stable for 1 year. We always exchange 1/2 of the ISG every year. So we'll have a stable set of people to talk to. That's good. The not so good thing is that the IETF is in this COVID-19 state right now, where the way we usually work is completely disrupted. And most people who have a management role, and that of course includes the ISG, are very busy understanding how to continue to operate in this environment. So it's probably not very successful to go to the ladies next week and say we want this to happen. But maybe after a month or so, we could be in a position to have these discussions and to prepare a little bit of consensus that might lead us to have a buff at the next IETF. Now, the next IETF is in July. And most people who understand what COVID-19 is tell me that there's no chance on the earth or in heaven or somewhere else that this will happen. But I think by the time this is supposed to happen, we will have a well-defined way to run this in a virtual way. So I think we should not be discouraged by that. We could start getting a consensus from the people who run the IETF about a month from now. We should have our ducks in a row in the way I described on the previous slides. Comments?
You will be the first boss.
No.
No,
Next week.
Yeah, this next drip is first.
Okay.
But close. But what I wanted to highlight here is, Carsten mentioned it takes a long time to get chartered and to get the first RFC out. That is true. But on the other hand, creating an IETF charter really focuses the scope with a lot of input and a lot of people asking you, why is this not more precise and why are you putting this in scope and this and that. So the review process of chartering is also a good enabler, even if we are not going to be chartered and therefore become a working group in the IETF. I think trying that and creating the charter focuses the work very well. And it is a good exercise at the very least, at the very, very least. And in the best case scenario, we become chartered, we get chartered and become a working group. So that is I have chartered only one thing, but that was a very, very good sharpening of the understanding of the problem, of the goals, etc.
I think we're well positioned with a chance for consensus. We have achieved quite a bit of consensus already, and we have a good working process that that sort of results in closure. And we have a lot of stuff to deal with, but also, I think we're in good shape there. And on implementation, I think we're in pretty good shape. So I don't think either of those is going to delay this. I think that the time frame sounds about right to me to come up with something. Thank you, Hank, for that. Yeah, even if it doesn't go forward, we will have a hardened charter and a good amount of review on our other materials. So even if we have to do something else, we'll have a much better starting place.
So in the chat, Michael mentioned that we could try to get an IAB BOF mentor. I think different people in this call have different experience.
Yeah, that's a hit and miss. Sorry.
This is a recorded meeting, so I'm not going beyond that. But yeah, we could.
So anyway, the steps are to the first engagement is with the BOF. So that's sort of the leading engagement with IETF then. And for us to do our homework is create a charter and probably start working on what an ID would look like. And those the things that Karsten had earlier in the slides about, we were going to have to demonstrate processing model and things like that, so we can start working on that and create action items to develop that stuff right away. And it sounds like things might come together to get started sort of between now and the Madrid timeframe somehow, at best.
Yeah, I think we need to talk to people. So there needs to be a lot of informal offline communication, and in particular, we have a new art AD which is coming in next week. I have tried to keep him informed about what's going on here, but I'm sure he will have lots of questions. So I think that's one of the first things we should be doing, try to get an informal meeting with the art ADs about this, and try to gauge what their concerns will be. But I think what Michael said is also true, that it would be really good to have a -00 internet draft, and that doesn't have to answer all the questions, but it should also identify where we already know that work needs to be done, and that for instance, includes the processing model. So I think we should use the next months to actually get this draft out there.
Writing. Yes, I totally agree with that. So, okay, how are we on time? Is this the end? This is the end, isn't it?
Yes, as we are already in the wrap-up phase.
When are we going to do this again?
This being the IRTF,
This kind of workshop.
IRTF one data model next step. Yeah, good question. It seems like we could do this again before too long, like sometime around this 1 month period even. The next IETF, the virtual IETF interims, are going to be mid-April, aren't they?
They're all over the place, because we are trying to decompress this highly compressed physical meeting into virtual meeting. So we have slots for that until I think April 28th. So that's when we are going to be done with the virtual interims that replace the Vancouver meeting. And we were lucky that we didn't get into that time period, because we are still before the IETF. Yeah, I think we can do a research group meeting a little bit more independent of what happens at the IETF. So if we want to do this in April, we could do that. Otherwise, it's probably early May.
Well, early May is the One Data Model online conference, tentatively scheduled.
Okay, so we should have something in our hands by that time.
Let's make that the checkpoint. Yep. Yeah. Good. Thank you.
Sorry, so this is Ege Korkan from Technical University of Munich, and I didn't know when to ask this question precisely. But from the discussions I see, the work is really closely related to the Web of Things thing description, and which also has the very similar model to the STF's model. And I couldn't see what are some more concrete differences. But then I maybe lack the experience.
That's a great question, because that will be one of the questions we will be bombarded with at the IETF. And we need answers for questions like this. So
Yeah,
thank
and
you
examples for how
popping
a one data model data definition gets used in a W3C thing description and how they work together. And hopefully even by then, maybe some concrete examples of them actually working together.
But from what I understand, so the model itself is just a model in the end, and then the STF is the language. So the model cannot be used since it's just a model. So
Well,
it's a model. It's the same level of definition as the IoT schema. So it provides you with terms that you can use as semantic annotation in a thing description for events, actions, properties, and things.
this is Michael McCool. I've been kind of quiet about this, but I'd like to comment. We should at least coordinate some activities. There's one thing in particular about the JSON schema that we definitely want to be using the same subset of JSON schema to be compatible. I think that's very important. And I think we also, as Michael Koster said, we need to work up some concrete examples to show that work together and where they are complementary. We are currently talking about thing templates and about class definitions and pointing to things. So I think we need to look at how we state formal relationship between the thing description and what it uses. We already have context though, so which may be sufficient if we're including a context. But I think there's also the issue of if the TD is an instance particular model, how do we say that? I think it would be nice if we didn't use different terminology as well. So if we can somehow, agree on common names for things, that'll be helpful too.
just
Make a list and then start figuring out what we need to work on.
yeah, just a little on what Michael Koster said, annotating thing descriptions with like similar to IoT schema with one model classes. So I mean, in thing description, we also have the context file which contains the classes. So I can double annotate in a thing description already with the by using its model. So it already has a model, and I can annotate with thing description model a thing description. So what would add to a thing description if I annotate it now with one data model?
You get application-specific class types. So you get a light switch or a light on-off control or dimmer control or color control with its defined data types in and out. So it's exactly like IoT schema. It defines the application layer types. It's the application vocabulary, if you will, for what type of thing you're describing that creates interoperability. So essentially, it's if I use semantic annotation that says, here's a thing description, this is a property in the thing description that's the on-off state property for a binary switch, then that's where that definition comes from. So
but this goes further than the property action event model of one data model.
What goes further?
So like I totally understand that we can, like for a light switch, we can add further annotations which are like more specific than just saying it's a property. I totally agree. But then this goes further than 1DM's property action event modeling. So this means you have more specific classes like an IoT schema.
I think we are running out of time here. We are starting to lose people.
Sorry, yes.
So I think these are all great questions, and we need to have this discussion. Michael Richardson's proposal was to do the same thing again on April 24th. At the same time, we are not going to collide with IETF virtual interims on that date because there are no virtual interims on Fridays. So yeah, Friday may not be my favorite time for this, but I think it's the best way to get something done in April.
Okay. Yeah, I would be happy to participate. Yeah, but as I said in the beginning, I couldn't just be sure when to discuss this. So maybe we can have a clear session for this, like in the agenda or something like this. It could be only, I don't know, 15, 20 minutes.
Absolutely, yeah. I think that we need to do that.
So relationship between W3C thing description and in particular this new idea, I forget how it's called, that there are actually classes of thing descriptions, templates or something.
Yes.
I think we could discuss that, and if we can find someone who can tell us about the templates. So Sebastian is also in the meeting. That would be great.
Can you hear me? Hello, can you hear me?
Yes.
Okay. Yeah. Hi, everyone. Yeah. I have to double check. I am not sure if there's the Eastern break, but the Eastern break is cancelled anyway. So it should be possible to join the next meeting in April. Yeah. But just let me know the appointment, and then I can introduce the thing description template idea.
Great. Okay. So we will have other things on the agenda, and then we, of course, we have a mailing list to discuss this. So we have some time preparing this, but I think we have made some progress today, and we just have to make sure that we write this up and have this available as documents to refer to in the working group process.
Great, thank you.
Ari, your last words.
Well, thank you, everyone. I think that was a very, very good summary, and I think we have a way forward roughly 1 month from now, hopefully with many of you taking things to the next level. And meanwhile, we'll continue to work on the 1DM group. So with that, thank you for joining, everyone, and talk to you soon again.
Bye.
Bye-bye.
Bye.